electronegativity. The first property that we discussed was atomic size, under which we discussed atomic radius and ionic radius. Second one was ionization enthalpy. Third one was electron gain enthalpy. And this is the fourth one, electronegativity. Now, before I give you the concept of electronegativity, let me tell you that both ionization enthalpy and electron gain enthalpy were calculated for isolated gaseous atom. Isn't it?
Yes, sir.
Which means that the atom must be isolated and must be in the gaseous state so that the process of removal of electron or addition of electron does not alter or is not hampered by the neighborhood. But today, the topic that we are discussing is completely different. And in order to calculate the electronegativity, the atom can never be in isolation. It has to be in combination with other atoms. So suppose we have two different atoms, A and B, which have shared a pair of electrons to form a bond. So you can consider this bond as a rope on the two sides of which we have two different teams. There is a sports called tug of war, which you must be aware of. And in tug of war, the strength of the team is determined by who is capable of pulling the rope towards their side. So whosoever is able to pull it towards that side will be the winner, which means that it will be proved that that team has a greater strength. Now, every atom is different, and every atom, due to their difference in behavior in terms of atomic size, nuclear charge, and all factors taken together, has been found to have a different affinity, love, and attraction for electrons. Say, if I call B as high electronegative, it means that B has more tendency of attracting the shared pair of electron towards it. And if this is high electronegative, it means that this automatically becomes low electronegative, isn't it?
Yes, sir.
Because it's a relative term. Out of the two, if I consider B is more electronegative, I could have taken A also, but conventionally we take the second atom as more electronegative. So you will see that if I say that B has high electronegativity as compared to A, so B will be in position of attracting the shared pair of electron towards it more. And the electron cloud, which was supposed to be present exactly in between the two atoms, is shifted slightly towards more electronegative atom. And this displacement of electron cloud towards the more electronegative atom will ultimately result in the development of a partial negative charge on the more electronegative atom and partial positive charge on the less electronegative atom. But if both atoms would have been exactly same, or even if they are different, they have same power of attracting the electron, then such kind of charges would not have been developed. So until unless the atom is in combined state, you cannot make out whether it is more powerful or less powerful. It is like saying that if I take an exam and I want to measure your knowledge regarding any particular subject, so I must provide you with some question paper, and on the basis of that question paper you will be getting some marks, which means that the marks are relative with respect to the question paper given to you. If it is tough question paper, so you will get lesser marks. If it is easier question paper, you will get relatively more marks. So your marks are relative with respect to the question paper. If I provide same question paper to the whole class, some are scoring good, some are scoring less. So the marks that every student is getting when compared, that is also relative in nature. So hence we say that when we are talking about electronegativity, it's completely relative in nature, because it is like saying that when A is combined with B, no doubt, I say that B is more electronegative than that of A. So therefore, B is taking the electron towards it. But suppose B is connected to another atom, which is more electronegative than that of B. So obviously, now the behavior of B will be completely reversed or not?
Yes, sir.
Yes.
Yes, sir.
So now out of B and C, who is more electronegative?
C.
Sir,
C is
C.
more electronegative, and that is why I have given del minus on C. So electronegativity is a relative term. And when we are to define the term electronegativity, so I can define electronegativity as, so write down the definition so that you can understand it in a better way and you can differentiate it from electron gain enthalpy. It is the tendency of an atom to attract the shared pair of electrons towards it. So the moment I use the term shared pair of electrons, it means that atom cannot be in isolation, isn't it? It has to be in combination.
Yes, sir.
So this is what makes electronegativity different from that of electron gain enthalpy. They are completely different. Whereas electron gain enthalpy was the energy change taking place, and this is the tendency. Now, tendency is something which cannot be measured in any scale. Energy change or energy has got a scale. It can be measured in the unit of kilojoules per mole, joules per mole, calories per mole, kilocalories per mole. But when you are to measure tendency, tendency is an abstract thing. Today, I have the tendency of eating sweets. I'm feeling like eating sweets. Now, you cannot have any measurement scale with the help of which I can find that how much is my tendency to eat the sweets. So tendency being an abstract thing cannot be measured in unit, which means electronegativity does not have any unit. It is just the tendency of an atom to attract the shared pair of electrons. And the knowledge of electronegativity helps us to understand the nature of the bond, as I said. So if a bond is of this nature, do you think the electron pair will be shifted to any of the direction?
No, sir.
No, sir.
No, because here the tug of war will be going on between two atoms which are exactly similar. Nobody can be the winner, nobody can be the loser. And as a result of which there will be no partial charges developed or no charges developed, which makes this particular bond non-polar covalent bond. Non-polar. The meaning of the term non-polar means no poles are generated, no charges are developed, So non-polar covalent bond. But suppose it is bonded to another atom B, which has more electronegativity with respect to A, but the difference is not that much. So there will be slight shift of the electron cloud towards B, making it del minus, and this is del plus. This is called partial charge, not complete. Complete means +1, +2, -1, -2, that is complete. But this is in fractions. That means, yes, displacement is going on, but not complete displacement is occurring. And this type of bond will be called polar covalent bond.
Sir,
Polar covalent. But
sir,
suppose, why so much of noise? Adrika, mute. Okay, so the third
Sir,
type of bond. E.
Sir, why B is del minus and A is del plus?
B is slightly more electronegative with respect to A, because of which there is pull of electron, but this pull of electron is slight, not complete. A is not completely losing away the electron, and that is why charges are developed, but incomplete charges are developed. Clear? Now, let us move on to the next example. Suppose there is A with another atom X. This is highly electronegative, and this is very less electronegative. So in that case, what will happen? In this case, X will completely take away the electron pair towards it. And in such case, X will develop complete negative charge and A will develop complete positive charge. And when this type of thing happens, so the bond is referred to as ionic bond. See whether this much it is clear or not.
Yes, sir.
Okay, I give you another example with the help of which you can understand it in a better way. Suppose there are two children of a father, and the father expires, and the property of the father is to be distributed among the two children. And because both of them belong to the same father, so they are supposed to get equal shares. Now, it has been found out that the two children have very, very small age difference in between the two. So there will be equal share, and accordingly, they will be equivalent to that of the first example, where both of them get the equal share. It is called a non-polar covalent bond. But suppose the elder son and the younger son has a more or less considerable age difference. Suppose the elder one is 30 years and the younger one is say 21 years. So there is a considerable age difference. So if the elder one gets slightly more share of the property, then we can say that it is equivalent to that of the polar covalent bond. But if the age difference between the two sons is very large, so though practically it is impossible, suppose the elder one is 30 years and the younger one is say 5 years only. The 5-year child hardly knows anything about the property. So what will the elder one do? Will he not take the whole share of the property, and
Yes,
the
sir.
younger one will be staying along with him without the property? Yes or not?
Yes, sir.
Yes, sir.
Okay. So just like the age difference matters during the distribution of the property, so here also the distribution of the electron cloud, shift of the electron cloud completely depends upon the electronegativity of the atom. If the electronegativity difference between the two atoms is zero, okay, there is no difference at all. When will the difference be zero? If both of them have same electronegativities, and therefore their difference will be zero. So what kind of bond you can expect between the two? Yes. What kind of bond will you expect between the two if the electronegativity so if the electronegativity difference is 0, then it will be a non-polar covalent bond. Say for example, O double bond O, Cl bond Cl, F bond F, N triple bond N, H single bond H. So what kind of bonds are they? Are not they non-polar covalent bonds?
Yes, sir.
Yes,
Understood?
sir.
Okay. So they are non-polar covalent bonds. Why? Because both the atoms are similar. Nobody can take any share because both of them are equally strong, and therefore there is no net resultant. Now, coming to the second part, A bond B, as I said. So if it is polar covalent bond, that means shift is going on, but not complete, slightly it is shifted towards B, so that it develops a partial negative and partial positive charge. So this type of bonding, which is called polar covalent bond, is found in the bonds like H bond Cl, O bond H, N bond H. I'm not talking about the molecules, I'm talking about the bonds. Okay. You don't have molecules like O bond H. O bond H is just name of the bond. So here I'm not talking about the molecules, I'm talking about individual bonds. So both of them are non-metals or not?
Yes, sir.
So whether it is H bond Cl, whether it is O bond H, so all are non-metals, and non-metals have tendency of gaining electron. Nobody would like to give away the electron. But even though the hydrogen is not having the tendency of giving away the electron, but as it is bonded to a more stronger atom, so it is bound to surrender the electron to some extent or not?
Yes, sir.
Upay nai ki koribo. So therefore, del minus on chlorine, del plus on H. Who is more electronegative out of oxygen and hydrogen? Del minus on O, del plus on H. Who is more electronegative? Nitrogen and this one. So you see that when the bonding is taking place between two non-metallic atoms with small electronegativity difference, electronegativity difference is there, but the difference is very small. So in that case, there will be not complete transfer of electron, rather there will be slight displacement of the electron cloud towards the more electronegative atom, and such kind of bonds are referred to as polar covalent bonds. Understood?
Yes, sir.
Okay. Now come to the third category, which is the bonding between a metal and a non-metal. So when a metal and a non-metal are bonded to each other, actually we are not supposed to show any line in between because they are ionic. There will be complete transfer. Say for example, NaCl, we put complete positive and complete negative. KCl, we give complete negative, complete positive. Are you understanding? So when I am giving complete positive and complete negative, it means sodium completely gives away the electron to the chlorine and chlorine completely takes away the electron, which means that this type of bond is called ionic bond, which is generally formed. Generally, no, it is formed between a metal and a non-metal. So metals have very low electronegativity. Such non-metals have very high electronegativity, as a result of which the electronegativity difference will be very large, because of which the bond will be ionic. Clear?
Yes, sir.
Others, is it clear or not? Adrika, is it clear now?
Yes, sir.
No. So thus, electronegativity is helping us to know the nature of the bond. And let me tell you that as far as the nature of the bond is concerned, I can categorize, first of all, the bonds into two types, ionic bond and covalent bond. Ionic bond is formed when electronegativity difference is too high. Covalent bond is formed when the electronegativity difference is either too low or not there at all. And covalent bond accordingly is further subdivided into two types, non-polar covalent bond and polar covalent bond. So this relative tendency of atoms helps us to understand the nature of the bond. But the thing is, what are the factors on which electronegativity depends upon? How do I know that whether an element will have more capacity of attracting the electron or not? There are various factors. Atomic radius. So all those factors which we have discussed under electron gain enthalpy equally is applicable here. Which type of atoms generally will be more electronegative? Smaller atoms or larger atoms?
Larger.
Smaller.
No, it is smaller one. Why? Because if the atom is small and if the atom is large, so don't you think that the smaller one will give the in between electron greater force of attraction? Yes or no?
Yes, sir. Sorry.
Okay. So atomic radius, siman horu hobo, lesser the size of the atom, more is the tendency of attracting the electron. Number two, nuclear charge, same. So which atoms are supposed to attract the electrons more? Those who have higher nuclear charge or those who have lesser nuclear charge?
Sir, less nuclear charge.
If you have less nuclear charge, it means that your force of attraction is less. If your force of attraction is less, will you have lesser tendency of attracting electron or more tendency of attracting electron?
Lesser.
Sir, less.
But so here we are talking about electronegativity. So what we can say, higher nuclear charge results in what? More electronegativity, isn't it?
Yes, sir.
Yes, sir.
Because if the number of protons in the nucleus are more, you have higher nuclear charge. Not only you will be attracting your own electrons, you will also have the tendency of attracting the shared pair of electrons. If the nuclear charge is less, so obviously you cannot think of attracting the shared pair of electrons, isn't it?
Yes, sir.
Okay. And stable configuration. How is stable configuration related to electronegativity? Those which have greater stability will have more tendency of attracting the shared pair or lesser tendency of attracting the shared pair.
Sir, lesser tendency.
Yeah. Actually, the stable configuration does not fit into it, because if an atom has a stable configuration, it will not combine with others, isn't it?
Yes, sir.
And if it does not combine with others, there is no question of pulling and pushing of electrons. So better not to talk about it. But other factors which also governs the electronegativity, I cannot discuss right now, because there are other, you can say, factors like hybridization, oxidation state, which you will get in the next chapter onwards. In chemical bonding, you are going to get the concept of what exactly is hybridization. And in redox chapter, you are going to get what is oxidation state. But simply remember that the two major factors which govern the electronegativity is atomic radius or atomic size and nuclear charge. Now, as I told you that electronegativity is just a tendency, and tendencies can never be expressed in units. So we have to depend upon other factors to actually measure the values of electronegativity. So time to time, different scales were given. Some of the scales that were provided were Pauling's electronegativity scale, okay, Mulliken-Jaffe scale. But we are not going to the details of on what basis the different type of scales were constituted. But let me tell you that Pauling introduced a scale of electronegativity on the basis of which some values were provided to every element. And what was the basis of his scale? The basis of the scale that he used were, you can say, bond dissociation enthalpy and other factors like electron gain enthalpy, ionization enthalpy. It is like saying, if I can tell you that there are two atoms and one of the atom has very high ionization enthalpy and the other atom has got very low ionization enthalpy, which do you think will have greater electronegativity? The one with lower ionization enthalpy or the one with higher ionization enthalpy? What do you think will be the answer? Who will be more electronegative?
Here,
There are two atoms A and B. This has IE1, this also has IE1, and IE1 of A has been found out to be greater than IE1 of B. Now, my question to you is, on the basis of ionization enthalpy values, how can you make out which one will be more electronegative?
sir, A.
A will be more electronegative. Can you justify on what basis you have said?
Sir, it has more tendency to gain electrons, so energy release will be greater. Why?
No, it's not a question of energy released. Ionization enthalpy is energy required. What is ionization energy? First, tell me. Is it the energy released or energy required? Think about it and tell me. What is ionization
Sir.
enthalpy? Is it not the energy required to remove the electron from the outermost shell of an isolated gaseous atom?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Now tell me, out of these two, removal of electron is easier in which one?
B.
Sir,
B.
A.
Sir, B.
No. IE1 is less. It means that you require lesser amount of energy to remove the electron from this as compared to this, isn't it?
Yes, sir. Yes, sir.
Now tell me, who has higher tendency of gaining electron?
A. B. Sir,
Of course, it is A, because if you can easily remove the electron out of it, it has more tendency of giving the electron rather than taking. And if it has lesser tendency to give away the electron, will it not have more tendency of accepting the electron?
Yes, sir.
Yes or no? Okay.
Yes, sir.
So on the basis of ionization enthalpy, more or less, we can determine that relatively who is more electronegative. Now, come to delta EGH. So delta EGH is the amount of energy released when an electron is added up to the outermost shell of an isolated gaseous atom. So if you want to find out that which atom has greater tendency of accepting the electron, can we not make it out on the basis of delta EGH as well? More negative the delta EGH, it means more has the tendency of this particular atom to gain the electron.
Yes, sir.
So combination of ionization energy and electron gain enthalpies can be used to find out relatively the electronegativity of an atom. So I'm not going into the details of how Pauling calculated, but just for the sake of understanding, I just wanted to say that on the basis of ionization enthalpy and electron gain enthalpy, which are established values for individual atoms, more or less we can make out. And according to the Pauling scale of electronegativity, the one which tops the list is fluorine with the value of 4.0. That means, according to the scale of electronegativity, fluorine is the most electronegative atom with highest value of 4, followed by oxygen 3.5, followed by chlorine and nitrogen 3.0, and thereafter all elements have been assigned different values. Clear or not?
Yes, sir.
Okay. It means that on the basis of these electronegativity values, among halogens, which are considered to be the most electronegative elements in the periodic table, so within halogens, if you are asked that arrange them in order of decreasing electronegativity, so fluorine is going to top the list. Fluorine, chlorine, bromine, iodine. Clear?
Yes, sir.
But when we were talking about electron gain enthalpy, it was chlorine, fluorine, bromine, and iodine. So this must be taken care of, because this is the relative tendency of attracting the electron, and this is the energy change taking place when an electron is added up. So try to understand the difference between the two. Are you getting my point?
Yes, sir.
Yes, sir.
So when I say I have the tendency, it's a different thing. And when I say when I get that thing, so in return, whatever amount of energy I'm releasing, that is the actual reality. It is like saying that suppose you are traveling by road and suddenly you come across a Mercedes car. Will you have the tendency of buying the car or not? Yes or no?
Yes, sir.
We all have the tendency of buying such expensive car. But what is the reality? Can we buy now? Is it possible for
No,
us to
sir.
buy it?
No.
That
No,
is the
sir.
reality. Okay. So that is the reality. So electronegativity is tendency and electron gain enthalpy is the reality. Understood?
Yes, sir.
So who is showing the maximum tendency of attracting the electron towards it? Fluorine. But later on, when it is accepting the electron feels some kind of repulsion from the electrons already existing within its shell, and thereafter it is found that no, it is the chlorine which is releasing greater amount of energy. So therefore you get a shuffling of the positions between chlorine, fluorine in electronegativity and electron gain enthalpy. Clear?
Okay, sir.
Sir,
Tell me.
sir, could you please explain this part once again?
Okay. What is the definition of electronegativity? Tendency of
Uh, the gaining
attracting,
electron.
tendency of attracting, no, tendency of gaining electron, no, tendency of attracting the shared pair of electron. That is electronegativity. Now, fluorine, being the most electronegative element, will have the highest tendency of attracting the shared pair of electron. But what is electron gain enthalpy? After that electron is added up to the outermost shell, in return, whatever amount of energy is released, that is called electron gain enthalpy, isn't it?
Yes.
So it is like saying that if you like something, okay, so you will have high tendency of getting it. That is a theoretical aspect. You have high tendency of getting this particular thing. But what will be the reality? You will have to pay something to get that thing or not?
Yes, sir.
Yes, sir.
Okay. Now, when you are paying for it, you find some difficulty. So that is the reality. Understood?
Yes, sir.
every one of you want to be the first boy or first girl in the class or not?
Yes, sir.
Every one of you want to top your class or not?
Yes, sir.
Is it possible for every one of you to top the class?
No, sir.
Isn't it? So that is the reality. So tendency is different. I want to have something. That is tendency. But in order to get that thing, what is the reality? How much should I release energy? How much should I work hard? That is the reality. Is it clear or not? So out of electronegativity and electron gain enthalpy, which is the reality and which is the abstract thing?
Gain enthalpy.
Reality is electron gain enthalpy. And what is the abstract thing? It is just the relative tendency of attracting. So it is electronegativity. Clear?
Yes, sir.
Okay. So in what aspect the electronegativity is helpful to us? It is helpful to us to know the polarity of the bond. Whether the bond is polar covalent bond, non-polar covalent bond, or ionic. Now, let us try to understand these three bonds. Okay. Who is the common element in all the three?
Oxygen.
Oxygen.
Oxygen. Okay. Now, what are the three elements that is visible on the board?
Oxygen,
Oxygen, hydrogen, and fluorine.
Okay. Now, let us consider this is a classroom of 3 students. Who is the topper in this classroom according to Pauling scale?
Fluorine.
Fluorine. Who is the second boy?
Oxygen. Oxygen.
Who is the third boy? Hydrogen, isn't it?
Hydrogen.
Okay.
Yes, sir.
Now, when oxygen is bonded to itself, will there be any shift of electron?
No, sir.
No, sir.
So, what kind of covalent bond it is?
Polar.
Non-polar covalent bond. Clear?
Yes,
Yes,
sir.
sir.
Now, in the second and third example, both of them are polar covalent bonds because atoms are different. Yes or no?
Yes,
Yes.
sir.
Yes, sir.
But out of oxygen and hydrogen, who has greater electronegativity?
Oxygen.
Oxygen.
So shouldn't I put del minus on it and del plus on it?
Yes, sir.
Yes, sir.
Sir.
But out of oxygen and fluorine, who is more electronegative?
Fluorine.
Fluorine.
So you see that the behavior of oxygen in all the three is completely different or not?
Yes, sir.
Yes, sir.
So it is the same oxygen, which is 0 here. 0 means no charge. Del minus here and del plus here. It means that as electronegativity is a relative term, so you cannot directly look at the atom and say that whether it is more electronegative or less electronegative until and unless you also know to which atom it is bonded to. Clear?
Yes, sir.
Yes, sir.
So you may be a topper in your class, but suppose you get transferred to a new place, and in that particular classroom, you cannot assure that you will be topper in that class as well, because there might be better students with respect to you. So initially, when you are getting position number 1 in the older school, when you shift over to a new place, you may not get position number 1. You may slip down to position number 2, 3, 4, depending upon the capability of the other students as well. So just like the position of a student in a classroom is a relative thing, electronegativity likewise is a relative thing, isn't it?
Yes, sir.
Yes, sir.
But when we talk about weight of a person, irrespective of whether you are in your older class or new class, it is not dependent upon who are your classmates. Your weight will remain the same or not.
Yes, sir.
Now your weight will keep on changing depending upon the nature of your classroom.
Sir,
Is
no,
it?
it will stay the same.
Not at all. So these are constant things. So likewise, ionization enthalpy is a constant thing. Electron gain enthalpy is a constant thing because it has nothing to do with the neighborhood atoms, but electronegativity is a relative thing and keeps on changing depending upon with what it is attached to. Understood?
Yes, sir.
Clear or not, everyone?
Yes, sir.
Yes, sir.
Okay, fine. So let us now try to understand the difference between the two. So write down the question or topic. Differences between delta EGH and electronegativity. Is it visible? What is delta EGH? It is
Electron gain enthalpy.
the energy change taking place when an atom, when an electron is added to the outermost shell of an isolated gaseous atom. Electronegativity. It is the relative tendency of an atom to attract the shared pair of electrons. Clear? Is the difference number one clear?
Yes, sir.
Yes, sir.
Point number two. It is calculated in isolation, isn't it?
Yes, sir.
This you put as point number one. This is point number two. It is calculated in combined state, isn't it?
Yes, sir.
Okay. Point number three. Yes, any other point which you can suggest? Any other point that you feel you can suggest to me? Fahim? No? Vayu?
Sir, it
No.
helps determine the energy change and electronegativity helps to determine the polarity of a bond.
So you can write down point number 3. It is absolute in nature. Absolute means it has a fixed value, does not depend upon the neighborhood. What should I write for it? It is relative in nature, isn't it?
Yes, sir.
It is relative in nature. Its behavior changes depending upon the neighborhood. It can be measured experimentally. Experimentally, you can measure it. It cannot be determined experimentally. Okay. Can I
Yes,
wrap the
sir.
first point?
Yes, sir.
Yes, sir.
Yes.
Okay. Point number 5, you can write. It is expressed in the units of kilojoules per mole or kilocalories per mole. What should I write under electronegativity?
Sir, it does not have any particular unit.
It has no units. Sorry, it has no units. Most importantly, number 6, among halogens, delta EGH decreases as chlorine, fluorine, bromine, iodine. What should you write on the right hand side?
Fluorine, chlorine, bromine, and iodine.
Fluorine, chlorine, bromine, iodine. Among halogens, electronegativity decreases as fluorine, chlorine, bromine, and iodine. These are 6 sufficient points to differentiate between the two types. Understood or not?
Yes, sir.
Yes, sir.
Okay, now one particular application of electronegativity that we have discussed is to predict the nature of the bond, isn't it?
Yes, sir.
One more important, have you all written down? Can I move on?
Yes, sir.
Sobe likhi sa?
Oh, sir.
Okay.
Yes.
So just as after discussion of every property, we used to apply it in the periodic table. So similar way, it's very easy to understand that what is the trend of or variation of electronegativity in periodic table. So as electronegativity depends upon the atomic size mainly, as well as the nuclear charge. So we can simply say, as we go down the group, electronegativity ki hoga? As we go down the group, atoms are increasing in size. So when it increases in size, will it have greater tendency of accepting the shared pair or lesser tendency?
Lesser.
Greater.
Electronegativity or tendency of attracting the electron will decrease, because as such it has more boundary, and therefore the nuclear force of attraction experienced by the shared pair will decrease automatically, isn't it?
Yes, sir.
And that is why fluorine, chlorine, bromine, iodine shows the trend that fluorine is highest and iodine is least. Along a period, the trend is always the opposite to that of what is shown down the group. So along a period, atomic size gradually decreases. So electronegativity increases. And because electronegativity is always compared in combination and group 18 elements do not combine, so accordingly, which group is finally supposed to have the highest electronegativity?
Group 17.
17.
Group 17. Yeah, group 17. So halogens as a whole show the highest electronegativity, but just after fluorine, it is not the other halogens, rather it is oxygen, which is the second topmost element in electronegativity. Clear?
Yes, sir.
Any doubt up to this much? Please clear it out. I hope it is clear.
Yes, sir. Clear.
Yes, sir.
So I was talking about the applications of electronegativity, how the electronegativity values of the atoms help us to understand. So one of the application has already been discussed. The first important application, of course. Yes. What was that? To predict the
Polarity of the bonds.
very good. To predict the nature of the bond. So in general, it has been suggested that suppose delta X electronegativity is actually denoted by Greek letter chi, which looks like X. But for our sake of convenience, we will consider it to be X only. So delta X is the difference of electronegativity. And suppose there are two atoms A and B. B is more electronegative as compared to A. So XB minus XA will be the difference of electronegativity. So the difference in the electronegativity helps us to predict the nature of the bond. If the difference exceeds 1.7 according to Pauling's scale, then the bond is referred to as what kind of bond? It is considered to be quite large difference. It is referred to as ionic bond. If the difference of electronegativity between two combining atoms exceed 1.7 according to Pauling's electronegativity scale, it is considered to be quite large, and I should represent such kind of bonds as A plus B minus. And remember, in ionic bond, we never give a bond in between, a line in between. Line is always given for covalent. If delta X is less than 1.7, it is called a covalent bond. But further, covalent bond is subdivided into two types, polar and non-polar. So for non-polar, what should be the value of delta X?
0.
Very good. There should not be any difference in the electronegativity. Both of them should be equally electronegative. And if the electronegativity is equal, the difference, of course, will be 0. And if it is greater than 0, but of course less than 1.7, then it is a polar covalent bond. It is denoted as A bond B del plus del minus. And for non-polar, we simply give A bond B without any charge on them, considering both of them have equal electronegativity. See whether you have understood this flowchart or not. Any doubt? If you have got, clear it out.
Understood, sir.
Understood.
Yes, sir.
Can anybody tell me what will be the nature of the bond if difference of electronegativity is 1.7?
Sir, it will be polar covalent bond.
But I did not write equal to. I have given only when it is greater than or less than. So always remember, if it is exactly equal to 1.7, it will have 50% ionic character and 50% covalent character. Okay, so it
Okay,
is
sir.
50% ionic and 50% covalent bond.
Okay, sir.
See, when you are moving from Assam to Bengal, say for example, okay, so there is a border in between every state, isn't it?
Yes, sir.
Yes.
Okay, so exactly at the border, you cannot consider it to be under Assam or under Bengal. And the same is true for international borders as well. If you happen to visit any international border, there is a particular piece of land which is referred to as no man's land. In between two countries, there is a large piece of land. What it is called? No man's
No man's
land.
land.
That means it neither belongs to that country nor this country. So 1.7, exact 1.7 will be considered as 50% ionic and 50% covalent. Understood?
Yes, sir.
Okay. Only when it is greater than or less than, we can decide that it is more what? Covalent or ionic. Can I rub it? Have you written it?
Yes, sir.
Okay. The second important application of electronegativity to compare the metallic and non-metallic properties. Okay, to compare the metallic and non-metallic properties. Now, who are metals? Metals are electron losers, isn't it?
Yes, sir.
Non-metals are electron gainers. ठीक है?
Sir.
So in order to gain electrons, electronegativity should be high or low?
High. Sir, high.
More the electronegativity, more is the key. Metallic property na non-metallic property?
Non-metallic.
Non-metallic.
And vice versa. Clear?
Yes, sir. Yeah.
So in the whole periodic table, we see that most electronegative elements lie on the extreme right. Forget the noble gases. And therefore, on the extreme right, we have more non-metals. And on the extreme left-hand side, we have very less electronegative elements. And therefore, they have more metallic character, isn't it?
Yes, sir.
So non-metallic character is directly proportional to electronegativity. Metallic character is inversely proportional to electronegativity. I hope it is clear.
Yes, sir.
Because these are minute things, but it helps us to know so many things which will be required in class 12 as well. And class 11, chemical bonding is a very, very important chapter, which comprises of the bulk of the things. And you cannot understand chemical bonding until unless the periodic properties and the different properties that we have discussed so far is crystal clear to you. Okay?
Okay, sir.
Sir, the electronegativity of metalloids is equals to 1.7.
Electronegativity of
Metal.
Metalloids.
Electronegativity in general, the individual values may be 1.7, but what I am saying is not electronegativity, is the electronegativity difference I'm talking about, isn't it?
Okay, sir.
Electronegativity can be 1.7 also, 4 also, 2 also, 0.7 also, but the polarity is not decided on individual electronegativities. It depends upon the difference of electronegativity. Clear?
Yes, sir.
The 1.7 value that I gave you is not value of an individual element. It is the value of what?
Difference of the
Difference. It is the difference. If the difference is 1.7, then okay. So this was all about electronegativity. Then we move on to fifth property, valency and valence electrons. Simple topic which you are already familiar with. They sound similar. They are similar for someone, but not always they are similar in every case. So valency is the combining capacity of an element. Now, what is the meaning of the term combining capacity of an element? Some atoms completely lose electrons. Some atoms completely gain electrons. And some atoms who are not in position of complete loss and complete gain share electrons. So that is called its valency. If there is complete loss and complete gain, that is called electrovalency. And if there is sharing of electrons, it is called covalency. It is the number of electrons an atom loses or gains or shares during chemical bonding. You know that atoms combine with each other to gain stability. Every one of us are unsatisfied in our lives. And that is why we work to get whatever we want. And this unsatisfaction is good for us. Otherwise, if every one of us are satisfied, we will stop working. Just like the noble gases. Atoms have either more than what is required or less than what is required. And therefore, to be in the borderline, they either lose electron, gain electrons, or share electrons. The number of electrons that they share, lose, or gain is referred to as valence. On the other hand, valence electrons are the number of electrons present in the outermost shell of an atom, isn't it?
Yes, sir.
On the other hand, valence electrons are the number of electrons present in the outermost shell. Now, as I said, suppose we consider the second period element starting from lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Okay.
Yes,
I
sir.
hope it is visible to everyone.
Yes, sir. Visible.
So when I write their electronic configuration, the thing will be more easier. It is 2,1. This is 2,2, 2,3, 2,4, 2,5, 2,6, 2,7, and 2,8. Say I want to calculate the valency, its combining capacity. So this will be 1, 2, 3, 4. And thereafter, it will not lose 5 electrons, 6 electrons, and 7 electrons, because it will be too difficult to lose electron. Rather, they will share the electrons or gain the electrons. So it will become 3 to 1. And it will not have any combining capacity. So I put a dash, isn't it?
Yes, sir.
So the first three have the tendency of losing electron. First two have highest tendency of losing electron, because losing up to 2 electron is more or less easier. From third onwards, it is relatively difficult to lose the electron. And thereafter, they will either share the electrons or they will gain the electrons. But valence electrons are something else. It is just the number of electrons in the outermost shell. See whether it is clear or not. So valency has nothing to do with the combining capacity. Whatever electrons they possess, that is the valence electron, isn't it?
Yes, sir.
Yes, sir.
So for some elements, valency and valence electrons are same. Up to carbon, it is same. But thereafter, you will see that it's totally different. Nah?
Yes, sir.
ठीक है? Problem 9.
No.
No, sir.
Now, when two atoms combine with each other, and suppose you want to calculate the formula of the binary compound. Binary means the compound comprising of two elements. So it is the valency that helps us to understand the formula of the most common compound. Say for example, I have carbon and oxygen. I want to find out that carbon and oxygen combine to form which common compound. It can form more than one type of compound, but which is more common? More common means more expected one. So what will I do? I'll write carbon and oxygen. Carbon is 2, 4. Oxygen is 2, 6. And then I'll put the valency. It is 4, this is 2, isn't it?
Yes, sir.
Okay. After that, in order to calculate their binary compound, I will cross multiply with their valencies. So it will come out to be C2O4, which can be simplified to give CO2. Clear?
Yes, sir.
Just see once. If you have got any doubt, you can clear it out. Don't calculate the valence electron, valency, combining capacity. So calculate the valency and thereafter cross multiply to get the formula. Try out the binary compound formula for magnesium and nitrogen. And tell me what will be the answer.
Sir, Mg3N2.
Yes. See, others are getting the same or not?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So magnesium is 2, 8, 2. Nitrogen is 2, 5. Let us put in the valencies. What is the valency of magnesium? It can lose 2 electrons and nitrogen can gain 3 electrons. Cross multiply. So it will come out to be Mg3N2, isn't it?
Yes, sir.
Yes, sir.
Okay. Try out for aluminium and phosphorus.
Al4P3.
Mm-hmm.
No, sir. Sorry.
Sir, ALP.
ALP.
Sir, ALP.
Sir, ALP.
The valencies of both are 3, isn't it?
Yes, sir.
ठीक है? Easy, na?
Yes, sir.
Magnesium and oxygen.
Sir, MgO.
Prove it.
Sir, both have valency 2.
Both
Yes,
have
sir.
2.
So MgO.
So it will be Mg2O2 or MgO, isn't it?
Yes, sir.
Yes, sir.
Okay. Is it clear up to this much?
Yes, sir.
Yes, sir.
Okay. Now the same thing, even though not required in this chapter, but it's better you know it, because nowhere you are going to get it, but application is required. There are some ions which are called molecular ions. Ions like O2 minus, P3 minus, Na plus, Mg2 plus. They have only one atom in them, isn't it?
Yes, sir.
So they are not molecular ions, they are atomic ions. But suppose you come across SO4 2 minus, CO3 2 minus, PO4 3 minus, CH3 COO minus, NH4 plus. They all are molecular ions. Understood why they are molecular ions? They are combination of atoms or not?
Yes, sir.
Now, when you come across the ions, so far we were discussing about atoms. But when you come across the ions, simply remember that whatever charge they possess, that will be their valency. Clear?
Yes, sir.
Now suppose I have aluminium ion and sulfate ion. They will combine with each other through ionic bond because they are ions. And we are given the task to find out the formula that they will be producing. So same concept you will apply. Aluminium 3 plus. What valency you will give for aluminium 3 plus? 3, isn't it?
Yes, sir.
SO4 2 minus. What valency you will give it? 2, isn't it?
Yes, sir.
Yes, sir.
So what will be the formula coming out?
Sir, Al2 SO4 3.
Al2, put SO4 in bracket 3. This is aluminium sulfate. Clear?
Yes, sir.
So this particular way of calculating the molecular formula comprising of ion is very important for us, because in general in the NCERT text, neither in class 11 nor in class 12, anywhere it is explained, but application part is very much required. So for that, you must be aware of these molecular ions. Say we have so many different molecular ions. So as far as I remember, I'm giving, this is called nitrate ion. So suppose you are asked to write the formula for magnesium nitrate. Magnesium nitrate. That means you need to find out the formula between magnesium 2 plus and NO3 minus. So accordingly, what will be the formula?
MgNO3 whole twice.
Are you getting MgNO3 whole twice?
Yes, sir.
Try out for aluminium phosphate.
Sir, AlPO4.
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 So both the valencies are 3. Aluminium is this, phosphate is this. So as you can see that they mutually cancel each other. So it will be AlPO4, isn't it?
Yes, sir.
Yes,
Clear or
sir.
not?
Yes, sir. Yes, sir.
Try out for lead acetate. Lead I have not given in the list, so include it, Pb plus 2. And acetate is this. It comes from acetic acid, therefore acetate ion. What formula you will get?
Sir, PbCH3 COO whole 2.
Now here you have to remember that it is the only exception. In general, cations are always written first, but in acetate compounds, it is always the convention of writing the acetate first. So it will be CH3COO whole 2 Pb. Remember it. Otherwise, in every case, we write cation first, then anion, except for this. Okay.
Okay,
Yes,
sir.
sir.
Write down the formula for ammonium phosphate. Ammonium, which is the ammonium ion? NH4 plus, isn't it?
Yes, sir.
Phosphate is PO4 3 minus. This is phosphide. If it is present alone, all are ending up with IDE, oxide, phosphide. Okay, and they are 8. So what will be the formula for ammonium phosphate? Tell me. NH4 plus and PO4 3 minus. Anybody getting it?
NH4 whole thrice PO
NH4 whole thrice
whole thrice
PO4.
PO.
PO4.
PO4.
Yes,
Okay,
sir.
sir.
PO4 is there, na? It is fixed.
Yes, sir.
Understood? How to get the formula?
Yes, sir.
Yes, sir.
So just cross multiply. And if it is atom, you need to know the electronic configuration. From that, valency is to be calculated. And if they are ions, then there is no problem because the ionic charge itself will be the valency. Now, nowadays, we don't talk about the valency anymore. Valency is an older term, and the valency term has been substituted by oxidation number, which you will get in redox. Yes, clear up to this much?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Okay. So next class, we'll finish off this chapter with some more small topics, which are very important as they are required in class 12. So see you next class. Bye bye. Good night.
Thank you, sir.
Yes,
Bye
sir.
bye.
Good evening, sir.
Thank you, sir.
Thank you, sir. Bye, sir.
Thank you, sir.